Jumping into our first video for Azure networking here, we're going to talk about the most basic components of your Azure network, and that's going to be your virtual network objects and your subnets. Got a lot of topics here to cover, so we're going to go run through really quickly what we're going to be talking about in this video. We're going to start by defining our basics. Our virtual networks and subnets as our base objects, how you plan for capacity for those, and then we're going to talk a little bit about some special case subnets. And by that I mean there are some that you have to create for certain resources, and then some that you can't control because they're going to be managed by other resources, so you have to be able to plan for those. Next, we're going to talk about some topologies, common ones, and then some settings related to those, specifically peering and how you configure peering in the different topology configurations. We'll talk about some of the Azure resources and how they interact with networks. It's good to understand this from a perspective of realizing not every resource connects to your Azure network. So it's not safe to assume that controls you're placing on just your network components are going to apply to everything unless you specifically configure those resources to connect. So you want to keep that in mind, and we'll talk about that. We're also going to go over DNS. It's important. I mean, DNS is kind of the lifeblood of any organization, so it's good to know how it connects into your virtual networks, how you manage those settings, and what are available to you. We'll touch on routing, not from an in-depth lesson on routing, but more from an Azure perspective of what routing is configured for you, how it's managed, and really how it works in an Azure environment. And then lastly, we're going to touch on network costs so that you have an understanding of where you're going to be charged for network resources and for data moving, because by default network objects are free, but they're not free. You pay for the data that's going through them and out of them. So we're going to talk about how that works, so you know from an administration perspective what you're going to be paying for. Let me cut over here quickly to my lightweight paint whiteboard here. And let's start by diving into the virtual network objects themselves. Now, your virtual network really consists of two primary objects. You have the virtual network, which is your top level container, and then inside your virtual network, you define subnets, which are the address spaces that your resources connect to. There's a few things to understand here before you create them. The main one is virtual networks themselves are really easy to create. You essentially create an IP space, or you create a network, and then you tell it what its IP space is going to be. So for the sake of our example here, I'm going to make our IP space 10.0.0 and slash. We're going to start with a slash 24. Let me just raise the font size here a little bit. All right. So let's say this is the IP space you create for your virtual network. When you create it, you define this IP space, and the only other factors that are important, which we'll talk about in a little bit, are going to be the subscription and the region that it's in. And we'll get to that when we talk about subnets. Now, sticking specifically to the IP space first, the important thing to consider when you're creating a virtual network is that any subnet you create has to exist inside the IP space that you defined at your virtual network level. Now, this is why I say a virtual network is your top level network object. It's essentially defining the boundaries for that network, and then the subnets themselves are what's actually defining the IP space that your resources are going to connect to. But they have to be in that IP space. So right away here, this is actually going to be kind of a problem, because if you consider a slash 24 network to be kind of your standard network size or network objects, and I created a virtual network with this slash 24, what I can't do is I could make this. I say I want to add a VM to this. I could make it this, I think. We'll get into some of the nuances later, but I think this would work. But let's say I make the subnet. Oops, where'd it go? Oh, you know what? Paint layers are messing with me. Let's say I put this the subnet IP space this. Now you see I've got hold on. Paint is doing something funny, which is expected because it's paint. let's try this again. Goodness. Bep, bep, bep. Good. Okay. I've created my VNet 10.0.0.24. Subnet, same thing. Now, this virtual network is full. I can't add anything else to it because this takes up the entire IP space of virtual network. So if I want to do 10.0.1.0/24, that's not going to work because now this IP space exists outside of this defined space. So this is the main and first point that I want to get across. Probably the main thing to consider whenever you're creating a virtual network is you need to define a top level IP space on the virtual network object itself that will be wide enough for any subnets that you want to include in that virtual network. So if I want to have this be my subnet configuration, two subnets, 10.0.0, 10.0.1, what I actually need to do is change the virtual network IP space to something that can encompass both of those. So let's set this to 10.0.0. I could do a /20, yeah, /23. That would be big enough for the two that I've created, but even that is a little bit small. So I would recommend making virtual networks at least a /20, or in a lot of cases you could probably get away with making a /16. That gives you the first two octets to work for, and then if you're working with any class C addresses and a 10.0.0, you have plenty of space then to define. Now, obviously, if you're coming from a networking background, you understand you don't want your Azure IP space to overlap with whatever you have on-prem. So that's the main thing you want to plan for, other than planning also for expansion in Azure. Now, I won't be able to tell you how to manage your on-prem network. I don't know what your IP space is going to be, but I can tell you from an Azure perspective, there is a serious amount of consideration you need to do for any future growth you might have within your Azure tenant, and those conflicts are going to come up once you start realizing that a virtual network is restricted to a region and a subscription. And the only things that can connect to that virtual network are other NICs that exist in that same region and in that same subscription. That means if you're using a single subscription, but you have resources, a virtual machine in East US and a virtual machine in West US, those are going to be in two separate virtual networks because you need a virtual network in West US for the West US VM, and you need a virtual network in East US for the East US VM. Also, this gets complicated when you start adding in multiple subscriptions, which, if you follow Microsoft's landing zone architecture, they talk all the time about democratizing subscriptions. Essentially, be okay with making a lot of subscriptions for different use cases. It's considered kind of a logical boundary that has a cost boundary associated with it. So it's very functional to create a lot of them and manage them through IAC. That way, if you need it, they're essentially easy to get and you can give them to everybody. Where that gets difficult is because virtual networks are tied to subscriptions. If you're going to create a lot of subscriptions, you have to be able to plan your VNet capacity to meet the number of subscriptions you're going to apply, which really comes down to don't make your virtual network IP spaces so large that you run out of IP spaces that are going to be available for other subscriptions that might also have VMs that need to connect. Now, we'll talk a little bit more when we get into the subject about Azure resources that use virtual networks. Other considerations are when you're actually going to need to create them, but that's going to be a little bit future. Now, as it stands, this whiteboard diagram would work. So I've got a 10.0.0/16, meaning I can use anything 10.0. Basically 255.255 or 00, anything after 10.0, right? So 10.0.0 works, 10.0.1 works, 10.0.255 works. That's all valid networks in this IP space, so the first two subnets I've got here work. Now, the other consideration you have to make with subnets is, by default, every resource, you can't connect a resource to the VNet without a subnet because you have to create a VNet, you have to create a subnet, and then the resources themselves connect to that subnet. However, there's a number of resources that require special subnets. To pull up a few here, let me pull up a different web browser. and see if I can find documentation to reference, because I'm not going to create these live in the portal. Let's bring this over. Deploy and configure an Azure firewall. The first thing it's going to say right here for product deployment, we'll talk about hub and spoke, where the firewall is in its own virtual network, there are local servers and peer network. So this is kind of unique. I'm going to ignore the rest of this and let's focus just on this. Azure firewalls, if you're going to create one, they require a subnet. The subnet has to be named Azure Firewall Subnet. Likewise, that's not the documentation. Here we go. If you're creating an Azure VPN gateway, which is required for any VPN connections, we'll talk about that in a little bit. They also require you to have gateway subnet, which is a defined IP space. I bring these up as examples to note that there are some Azure resources. These are the two that I know off the top of my head. There might be more. That when you set them up in the portal, they first require you to configure a subnet that has a very specific name, and some of them have specific IP space requirements in order to create it. Because essentially, you create that, and then that resource, that's the subnet that they use, and nothing else uses that. Nothing else can connect to it. So there are resources like that that you have to pay in mind. So you want to plan for, when we get into the topology, I'll talk a little bit about planning for the potential of a network to be used for one of these resources. And really, it's going to be like a network appliance type resource, like a VPN, like a firewall that's going to use them. The other things that you need to plan for, and this goes back to the kind of dedicated or managed subnets, is there's some resources like VNet integration on an app service plan that need to manage their own subnets. So when you are planning for your capacity, I've got 10.0.0.16, that's plenty of space. But if you need to do smaller virtual networks because you're planning on the potential of having a lot of subscriptions and a lot of virtual networks, and you want to make sure you don't run out of IP space, or your networking team has only given you a couple of /16 networks that you have to work with, so you're dividing this up into like a /20 or something smaller. You need to plan for the potential of having subnets that are going to be dedicated that you can't control. So an app service plan in Azure is used to run app services, which are essentially containers. And if you're going to do a virtual network integration, which we'll talk about when we get into Azure resources, when you connect that VNet integration, you assign it a subnet, and Microsoft recommends nothing smaller than a /27, I think. Maybe even a /25. I have to look up the documentation. So that's a whole chunk of addresses that you're giving up. Once you give that subnet and give it to that resource for management, you can't use those IP addresses anymore. That IP space is now given to something else to manage. So there's resources like that in Azure that are going to have their own subnets, and they're going to manage those subnets, and they could potentially need very large subnets. So capacity planning in Azure is kind of an art form where you have to take into consideration how the virtual network is going to be used, what IP space you're going to have available versus what IP space is going to be managed or taken from you out of that chunk that you've already dedicated to that virtual network. And you need to plan for virtual networks that potentially could be big enough to conflict with each other. Make sure you have enough space for everything. It's an exercise. So it's not a simple process, but it's something that you'll get better at. And if you're looking for very general advice, and I'm going to break this down to basics, stick to what I've got here in the example. Essentially, a /16 network, if you've got plenty of IP space and you're not working with a super large on-prem example, /16s are easy. They're very recognizable because you're only looking at the second octet to delegate that, and they have plenty of IP space in them. So if it has a very basic general rule of thumb, just create virtual networks with /16s and you should be fine. That's assuming You don't have a network team on-prem that's putting some rules, but if you have that, then you can work with them and they can help you do capacity planning, and you can focus on more of the administration tasks. Okay, our next topic we're going to get into quick is virtual network peering and how that works. And I'm going to pull up an example here in the portal. All right, I've got my lab subscription pulled up here, and you'll notice I've created 3 virtual networks. And the reason I've created 3 is I want to run through 2 separate topologies with you, the common ones being mesh and then hub and spoke. Now, I'm going to preface this by saying I can't actually configure hub and spoke network because one of the prerequisites is that you have a gateway configured, and that's either a VPN gateway or an Azure firewall. I don't have either, and I'm not going to pay for it for this video for the time being. So I'll show you how to do it, but I'm not actually going to have it enabled. But we'll start out by talking about anytime you're configuring a network topology, that starts by configuring VNet peering. Now, VNet peering is literally just connecting one VNet to another, and it's really simple. If I pull up my first VNet here, on the left-hand side, I've got peerings right here. And all I have to do to connect them is click Add, and then I type in a peer name, allow access, and then what you're actually doing when you create a peering, you used to have to do this in separate steps, so they kind of consolidated it down because it was redundant. But when you create a peer, you're not actually creating one peer, you're creating 2. You're creating one to connect your first network to the second, and then a second one to connect the second network back to the first. So this is your first connection, and this is our second one. So I'm literally going to name it the opposite, VNet 2 to VNet 1. And then deployment manager doesn't matter, no one ever uses classic. And the last thing you got to do is select your second virtual network. And this is literally the settings to configure a VNet peer. Very straightforward. Now, if I were to connect this, it would go ahead and connect the networks. Everything would work. Traffic would flow. We'd be fine. But let's pause here for a second and let's talk about network topology. So I'm going to cut over quickly to my Paint whiteboard again. And we'll talk about 2 different topology scenarios, the mesh and hub and spoke. So I've got a diagram of the VNets I have configured right now. Where's my brush tool? All right, so this is 1, this is 2, and this is 3, right? VNet 1, 2, and 3. And 10, 0, 10, 1, 10, 2. So not complicated, right? To configure hub and spoke, which is the recommended VNet configuration, because it scales a lot better than mesh network, which requires you, for every VNet you add, to then go and touch every single existing VNet to add a link to the new one. It doesn't scale well, but it works for a small business. It's only going to have a couple VNets. It'll work just fine. And it does enable connectivity directly from VNet to VNet. But the reason hub and spoke is recommended, it scales better, and it's generally advised that you use firewall appliance or a security virtual appliance to route traffic outbound through, so that you can control your traffic, have better, can implement security on any outbound traffic, and then you also have a mechanism to perform NATs, not using load balancers, but it's best practice to have a security device. And if you're going to do that, you can place your security device in your hub network, being the network that all traffic routes through, and you can do one of 2 things. You either have it filtering all traffic that's going outbound, or you could literally have a hub network, a central network that is just for a firewall, and then every single bit of network traffic that's going east-west from like VNet 2 to VNet 3 has to go through the firewall in VNet 1 to get to it. That way you're doing east-west filtering and north-south, because outbound traffic will go to it too. Now a hub network in this case would look like, find my mouse here. Okay, let's assume this is our hub network right here, right? That means we want to route traffic. Any traffic that gets connected goes through that. So the way we would do that is you'd run a VNet peer from here to here, and then you'd run a VNet peer from 3 to 1, and then all outbound traffic would then go out this way. So you've got your 2 you have two peers in this case. You'd have a peer from 1 to 3, and you have a peer from 1 to 2. And then if your VNet 3 needed to talk to VNet 2, and that was allowed, it wasn't blocked by policy or a route or something, then in order to get there, the traffic from here would go through VNet 1 and then back to VNet 2 that way. And then this would scale. So if I were to add a fourth VNet, oh, hold on. Let's just say I've got another one here. In order to connect this one, all I have to do is then create a new peer back to my hub network. And now I can connect from 2 to 4 going through that network as well. So this is why hub and spoke are generally recommended for enterprise networks, is because it gives you a central point of control for all network, or for all network activity, because you know all network activity has to flow through that subscription and that VNet. And then also it scales really well, because when you add a new VNet, you add one network connection, and now it can speak to anything else that it's allowed to speak through given your rules. It's simple, it's scalable, it works, and then you can also configure all of your core networking components, your firewalls, your VPN gateways, into your first network here, and then that gives you connectivity directly to all of your other VNet peers through it. So this is the best practice. This is the ideal, right? Now, mesh, on the other hand, let me just get rid of our fourth VNet here. We don't need it. Mesh doesn't scale well, but is a little bit simpler to connect or to understand from an activity standpoint, and that is literally just doing a VNet peer between each VNet. And this way, if I need to talk from 3 to 2, I go straight there. If I need to talk from 2 to 1, it goes straight there. 3 to 1, straight there. So in a small demonstration like this, where you have just 3 networks, mesh is 3 peers, it's really simple. Now, going back to that previous example, I probably should have just had another paint layer with this. If I'm going to have 4 networks and I need to do mesh, actually let me throw it up here where it's not blocked by my webcam. Now I need 1, 2, 3, and if I add that 4th network, I then need a peer from here to here. I need a peer from here to here. And I need another peer from here to here. This is obviously a mess, but now look at that. Well, I've added 1 network, and that is now 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've doubled the network connections, and math is hard. I'm not going to try and scale. It's really hard to scale, but it gives you direct network-to-network connectivity. Like I said, this will work fine if you're a small business and you're only going to have a couple of virtual networks. It's going to be very difficult to scale up if you're doing any sort of size, or if you're adding a lot of subscriptions and each of those subscriptions needs its own VNet. So caution when you're doing this, I guess. But if we're going to configure this from a network Azure perspective, let me go ahead and switch back to my browser here. Let's run through these actually in the same order. So let's configure what it would look like to do a hub and spoke first. This is just a couple of extra checkboxes, but it would get working. Let's assume for this example, VNet 1 is our hub network. We want all traffic to route through VNet 1. In order to do that, all we would have to do is check this box, allow gateway or route server in VNet 1 to forward traffic to VNet 2. This essentially assumes you have a gateway device in 1, and that's going to be forwarding traffic to that network. And then from VNet 2, remember, we're creating 2 peers here. We have our first one, which is VNet 1 to VNet 2, and down here is the settings, the opposite, traffic going from VNet 2 to VNet 1. In this case, we do the opposite. So this says allow gateway. In this case, we'd say enable VNet 2 to use the remote gateway on VNet 1. And I don't think this will work. I'm pretty sure it got blocked. Failed to add. Yeah. Cannot have use remote gateway if that's true, because remote virtual network does not have any gateways. So that's how you configure it. It won't let me. But then I have that peer configured. Now this is still VNet 1. The next thing I do is do the exact same thing for VNet 3. So I do VNet 1 to VNet 3. I'd allow this gateway that's in my network to be used in 3. And then my peer is going to be 3, 2, 1, select my 3 network, and then check this box and the same thing. And now what that's doing is, if you're in VNet 2, you're going to route your traffic out through VNet 1 and use the gateway there to go anywhere else you need to go. If you're in VNet 3, it's the same thing. You're sending your traffic out to VNet 1 using the gateway there, and they can go anywhere. So that's hub and spoke network. Very simple. Now, if I go back here, let me see how this configured it. So this is my, remember I said these peers are 2 objects. From 1 to 2 perspective, this kept the settings, but I'm going to uncheck this. If I was going to convert this to a mesh, I've got 1 to 2. Let me pull up my second VNet, go to the peer, and I think this is probably unchecked. It didn't even create the peer. So so right now, my traffic right now will route from 1 to 2, but never 2 to 1. So there's only one-way connectivity. So let me go ahead and finish this by adding the opposite peer. Actually, rather than do this, I'm just going to do this all from VNet 1, so it's not conflicting. So let me delete this. Yep. Now this is how we configure a mesh network. This is a lot simpler. Now, I don't have gateways anywhere, and if you're configuring a mesh network, you really would have to take that in consideration. And realistically, you're following best practice and you have all outbound traffic going out through a firewall, you would need then a firewall in every single VNet if you want this to be effective. And then you'd have to you'd use the gateway in your local VNet, but it could route out through other networks as well. I don't even know how that's supposed to work, so I'm not going to think through it or try to explain it to you. But there's a lot more considerations in doing this if you want to be following good security practices. But just for a simple mesh network setup, it'd be very easy. I just do this, and then I do the opposite. I wouldn't check any other boxes. I could allow it to receive forward traffic. I could probably check that both ways. And then I select my network. That's my first peer. Do the exact same thing here. Now I've got 1 to 2, 1 to 3, and the last thing I gotta do is go to 2 and then run 2 to 3. And there you go. That's a mesh network. Like I said, more considerations than just doing this really quickly, but this is the basics of setting up VNet peering. It's pretty simple. Now, I'm supposed to talk about Azure resources and DNS, but let's pause here instead and talk about routing, because setting up VNet peers directly corresponds with Azure and how it does routing. The nice thing about Azure is, for the most part, it does all the routing for you. You don't need to think about it. So if you peer VNet 1 to VNet 2, it's going to configure the route so your traffic just knows how to get there. And the way it does that is, I probably should have double checked this before I record a video. There is peers. There's a way to look at the route table. Okay, I had to pause here for a second, look up how to do it. The reason I couldn't find this, and I remember seeing it in the Azure portal before, the reason I couldn't find it is you can view effective routes not by looking at the VNets themselves, but you look at connected network interfaces, and then you can click on effective routes, and this is a screenshot of it. I haven't spun up a VM. I don't have one ready. I'm not going to bother because this is just a quick topic, but I just want to pull this up to show. When you create a VM, you can create a NIC, you can click on effective routes, and it will show the route table that's populated. Now, this is going to be specific to whatever the environment was that the user had on this VM. So it's not going to match mine. But this route table, effectively, is populated by the VNet peers. When you create a peer, it appends that peer to the route table so that those networks know how to get to it. Essentially, it says address prefix, next hop type, and it'll list all of your VNet address spaces here. Once you configure a peer, it manages for you. And the point of the illustration, this is not a very good one, I realize that, but it's to show you Azure's going to manage all this for you. So if you have VNet peering and you're doing that use remote gateway, allow gateway, the part of the reason that you're creating those settings is it's going to define that route here, and it's going to say to get to this address space, use this gateway in this network, and it manages that for you. Now, the other thing that's nice is if you're configuring ExpressRoute or if you're configuring VPN connectivity on-prem, it also uses BGP to go ahead and look up and get the routes for your on-prem networks so that it can populate these for you as well. So I know it's possible to configure this without BGP, and there may be some scenarios where you'd configure your own route table if you need to define your on-prem routes. But for the most part, if you have BGP enabled, Azure will look up your on-prem networks and it will populate those routes for you, and it's all transparent and you don't have to manage it, just like if you were on-prem. It's really nice. Now, I mentioned route tables. You do have the ability in Azure to create, I call them UDR, user-defined routes. Or it's just going to be a route table. And this is exactly what it sounds like. It's just going to be routes that are you link to subnet, and then it automatically applies to any resource in that subnet. So go ahead and create this, because literally it's just an empty table when it's first created. The main place I see these used is if you are trying to force outbound traffic to a specific network appliance, like your Azure firewall, or if you have a managed firewall that you've stood up on yourself in a VM, or if you're using a VPN device and you need to get on-prem. I don't think you have to manage the routes in that instance, but yeah, every time I've seen it, it's been to force outbound traffic through a network security appliance. So in that case, all you do is go to routes, you'd add one, route to internet, destination IP. You'd put your IP address of your firewall. Let's just say this is this. It's going to yell at me because I don't have. Oh, this is my destination. So if I'm routed to internet, my destination is 000/0. Next hop is going to be virtual appliance, and then you put in the IP address of your virtual appliance. Click add, and now all of the traffic to your that's destined for the internet is going to force it through virtual network appliance that you have defined at this IP. And then from here, you can go to subnets, link it to a subnet. And now any connected VM or service in the subnet that you've linked it to is going to force outbound traffic to the internet out through the IP address to the device at the IP address that you specified. That's how you force outbound routing through a network security appliance. It's how you do it with Azure Firewall if you're configuring that. It's how you do it with other managed NVA if you have another one. So the nice thing is this merges with existing routes. It doesn't overwrite them, so you'll still have connectivity to your other VNets. You don't need to bother trying to copy that table, but it does have. This is how you force traffic, and this is as much as I'm going to get into routing. Just to be honest, it's not something I think about every day, and it's not really something I want to manage. But from an Azure perspective, this is something that's good to know. Now, I skipped ahead. I talked about routing because we were at the VNet peers, and really, when you create peers, it creates routes, so it's a natural step. However, let's cut back and talk about Azure resources for a second. Most people, when they start out in Azure, they assume that when they create a service, it's connected to their network somehow. And there's oftentimes this gray area or this misunderstanding between your VNets and your defined network space and your other resources in Azure being like PaaS services like a storage account. Now, if I click back to my lab VNet, I've got a couple of PaaS services. I have a storage account here that I use for Terraform State when I'm creating and destroying resources here. If I go to networking on this resource, right now I have public networking enabled, but I don't have a place in here, you'll notice, to configure like an IP address or to choose a network that is associated. Now, this is saying network access. I can say enable it from selected networks, and I can add existing VNets here, and that will allow this to access this resources. But when you're allowing this, you're not actually connecting to this resource through your virtual networks. What you do in this case is you would be configuring this firewall rule so it's allowed to get to it, but then you have to go to that VNet and also create a service endpoint for storage accounts so that it knows how to route from that VNet to the storage account. But that's not private network connections. If you need to connect PaaS services to a virtual network, you have to use what are called private endpoints. So that's going to this private endpoint connections tab. I'd create a new one. And endpoint storage. Now the region's important. The endpoint has to exist in the same region as the VNet, but you can choose a VNet that's in a different subscription. So if I create my PaaS services as one subscription, I can create the VNet to connect to them, or the private endpoint to connect to them in the separate subscription that has my VNets in it. So it gives you a little bit more flexibility. Let's say blob, and then I choose my VNet and my subnet. I don't need that. This is going to create a private DNS zone for me. DNS is a whole nother consideration. We'll talk about that in a second, but I'm not going to get into how private endpoints work from a DNS perspective because that'd be an entire its own video that comes with everything. But if I create this, what's going to happen here is it is going to actually create a NIC for this storage account, and then NICs are what actually associates with virtual networks, and that's kind of a core component to understand. If you want to connect anything to a virtual network in Azure, it needs a NIC. And when you are connecting a PaaS service to a virtual network, it's creating that NIC and then connecting the NIC to the PaaS service on the back end. But the NIC is what's assigned to the IP address in your private IP space. And then if it's got a private IP address, at that point, anything that's on that virtual network can talk to that NIC using that private IP address, or can talk to that PaaS service using that IP address, and the traffic's routed through the NIC. Now, the reason I keep mentioning the NIC and the reason that's important is if you think back where I mentioned when you're capacity planning for a virtual network and you want to make sure that you have enough, you're not conflicting IP spaces, and that virtual networks are restricted by your subscription and region. The NIC is what has to exist in the same region and subscription in order to connect to that virtual network. If you try to create a private endpoint in a different region, you're not going to be able to connect to that VNet. So if you create the private endpoint in West US, it has to connect to a VNet in West US. It can't connect to a VNet in East US. Similarly, if you create try to create a private endpoint in subscription 2, and your virtual networks are in subscription 1, it's not going to be able to connect because it needs to be in the same subscription. So that all factors back to where the NIC exists. Now, the other reason I keep saying NIC is the primary resource that connects to a virtual network by default is your virtual machines, your IaaS infrastructure. And if you think about a VM, when you create a VM in any virtualization technology, Hyper-V, VMware, anything, you create a network interface card for that device, and that's what it uses to connect your virtual machine to your network. Azure's exactly the same. You create a VM, it creates a NIC, the NIC connects to the VNet. Likewise, a PaaS service can't connect to the VNet unless it has a NIC. So NICs are your interface to everything. And the reason why it gets harder with a VM is a VM usually has to be created in the same subscription and region. And that's where network capacity planning gets confusing. But the reason I'm talking about this primarily is because when you first start out, people get that misunderstanding. They don't realize your virtual machines and your VNets are going to be on one network, and your PaaS services are going to be in the Azure data center. It might not go through the public internet depending on how you have your PaaS settings, but it's not connected to your VNet unless you go through the extra steps of creating that private connection. And then just to close the loop on this, oh, I didn't actually create this. What that means is you have to connect. The virtual network is a standalone object, and you have to have special considerations or extra considerations for PaaS services like storage accounts or anything else. The other thing that gets people when they start configuring PaaS services and they start using private endpoints to connect those PaaS services to their virtual network, which a lot of companies do. It's kind of a standard now because once they're configured or connected to your private networks, you can then remove any internet access from that PaaS service, and now you have private routing or private connections to those PaaS resources, and it removes the internet as a factor of or attack path. So you now can just focus on controlling your virtual network, and you don't have to worry about anything else. Now, the thing that people don't understand then is if I connect the storage account, like I'm doing right here, I'm creating a private endpoint, it's connecting to my virtual network. If I had a VM, I could then use the VM to connect to the storage account via a private address instead of a public one. But a lot of people think then that goes both ways. However, you have to think most PaaS services don't send outbound traffic anywhere. So you don't really need to think about the fact that traffic goes both ways. It's only going to be receiving traffic. And the reason that's important is you only really have to worry about firewall or network communication one way, inbound from PaaS services. And while there are some services that do outbound traffic, those are going to be your resources that need like those delegated subnets that I talked about in the very beginning. So I used the example of app service plan or an app service that uses a VNet integration. When you enable VNet integration, that's actually a separate configuration from your private endpoints. When you pull up an app service plan and you're working and you pull up the networking pane, I'm not going to do it because app service plans are also expensive. Let's go back to here really quick while we're creating this. Your app service plan has two options. You've got your private endpoint, which essentially is your inbound connections, and then you have a separate section for your outbound connections. And default, outbound just goes out through the internet. So it's like, and this applies to any container you have running. Any outbound connections just go out through the internet. However, your outbound settings are where you configure your VNet integration. And what that is doing is saying you now you designate a subnet or an IP space that app service plan could then use, and now any outbound traffic connects to that subnet, and you can apply an NSG or a firewall rule on that subnet, and then you can apply a route to that subnet so you can force traffic out whatever direction you want from that that app service. But the reason I call it out is that's one of the only instances where a PaaS service is going to be sending outbound connections. The other ones I can think of is like a function app, which you might have code configured that talks outbound for some reason, and those need an outbound route. But that's the special sort of consideration that you have, and I only call it out because you only really need to think about it in certain instances. And as you start thinking about the different types of PaaS services, it makes sense which ones actually need outbound connections, and really those are the only ones that are going to be intelligent enough to be initiating or retrieving data from somewhere. Otherwise, for the most part, PaaS services are only ever used to receive data, to ingest things. So a private endpoint is really just inbound traffic for that resource, period. Now, we've got our private endpoint stand up here. If I click on this NIC, it shows it's connected to VNet1 in my default subnet. It shows its private IP address of 10.0.0.4. And now if I go back also to my storage account and go to networking, this is still allowing access from anywhere. So at this point, what I could do is disable this. And now public access is not allowed, but any VM I have connected to this subnet would be able to talk to it using this private endpoint connection on the 10.0.0.4 address or whatever was designated. And the other factor of that is DNS, which leads into our next statement. DNS from a private endpoint's perspective is really complicated. I'm not going to get into it. But from a connectivity standpoint, if you want your virtual machines to talk to your on-prem resources, you need to know, how you control DNS. By default, Azure has its own set of DNS that allows special resolution if you're a resource within the Azure data center to other Azure resources. Like if you're trying to query from a VM to a storage account that's in Azure, it's going to respond using its internal DNS servers. It'll still be an external IP address, but then routes that traffic through the Azure Data Center, which is different if you choose to use internet routing and then force that traffic out. However, you have two options of configuring DNS for a virtual network. One, you can configure private DNS zones. Now, you'll notice I have one. When you create a private endpoint, it creates a private DNS zone for you. But let's assume this is for a special suffix that's used for this resource. But let's assume this is my company DNS, or I'm using like a contoso.local DNS zone. I can manage records here. I can go ahead and create A records. I can create CNAME records, and it'll resolve anything in contoso.local. The only thing then I have to do is configure what's called a virtual network link. And this is literally just associating this private DNS zone with a virtual network. And when you associate it, or you link a DNS zone to a virtual network, now any resolution for this domain name, the domain name that the zone is tied for, is going to just work. So if this was contoso.local and I had it linked to the VNet 1 and I had a VM on VNet 1 that was trying to ping vm2.contoso.local, you would see that contoso.local is linked to that VNet, and then it would resolve based on whatever records are in this zone. So that's one way to do Azure DNS. You can create and manage your own private DNS zones. They're cheap, they're lightweight, they link easy, they do work really well, assuming you have a system for managing those links, because really that's the most important factor. However, a lot of people have VPN connectivity or ExpressRoute connectivity, and they don't want to use Azure DNS servers. They don't want to use a zone hosted in Azure. They have their own local resource zone that they want to resolve. I have a VM in Azure. I want it to be able to resolve my domain controllers or my on-prem servers or my on-prem workstations. I need that sort of DNS resolution between the two. If you're going to do that, it's pretty simple as well. All you have to do is pull up the VNets settings, and then right here you've got an option for DNS servers. By default, it defaults to the Azure provided DNS. However, you can choose custom and add as many DNS servers as you want here. And when you add this on a VNet level, it automatically inherits down to anything, any subnets that are in this virtual network. It says right here, there's other considerations, primarily that if it's VMs, you have to restart the VMs before they'll pick up the new DNS settings, but that's how you do it. You just come in. It's just like configuring DHCP settings on premise, where you specify the DNS servers. All you're doing is going to setting to custom, set the IP address of your DNS servers, hit save, and there you go. So that's how you configure DNS in Azure. Okay. We've covered the topics we're going to go over. We talked about capacity planning, virtual networks and subnets, IP addresses. Went over peering, spent time talking about the different topologies. We went from that, we touched briefly on routing, basically to make the point that Azure handles routing and route tables for you. So unless you have a reason to, like to force outbound traffic to a specific device, you don't really need to mess with routing. It just works. And we went from there to talk about connecting resources to VNets, specifically mentioning VMs connect to VNets, but by default nothing else will. So if you want to connect to other PaaS services or other resources in Azure, you have to do the extra steps of configuring private endpoints or whatever configuration is required for those. Finally, we wrapped up talking about DNS. You've got two options, well, three options. You use default Azure routing, you use private DNS zones that you can then link to VNets to allow resolution to that zone for any link to VNet, or you come into the DNS settings on the VNet itself and specify custom DNS servers. Easy, right? The last topic we're going to cover is going to be virtual network pricing. And this is going to be really easy. There's two components, and I'm actually going to pull up the pricing page so that we can make it obvious for you. By default, creating a virtual network doesn't cost anything. Having subnets doesn't cost anything. However, there are a couple of things that do cost money. One, crossing VNet peers, meaning if you have VNet 1 peered to VNet 2 and you have traffic going from VNet 1 to VNet 2 and back, and you have lots of traffic, you're going to be paying 1 cent per gig that's crossing that peer. And that's inbound and outbound. So traffic both ways, you're going to be paying 1 cent per gig. So essentially you're paying, if you're sending traffic back and forth, 2 cents per gig. So only really consideration if you're sending a lot of data, but if your network's scaling up and you have a lot of components, this does become a charge you have to consider. There's also different costs if you're doing global VNet peering. I'm pretty sure this means you're crossing VNet peers that are like international or across large uh, um, geographic distances. I'm not going to get into this. Just know that you have to consider it. Essentially, so this is cost number one that you have to consider for Azure. Any VNet peers you pay for, or any traffic crossing it. The other cost, which I don't see listed on this page, but is just kind of a global rule of Azure, you pay for outbound traffic. So, bandwidth pricing, there it is. So, data transfer between availability zones, not going to talk about it. So you try for crossing Azure regions or internet egress. This is the one I was thinking about. Any egress traffic, that means traffic that originates from Azure and travels out, you pay for. And it looks like they've got a lot of different types of prices. It's not as simple as the 1 cent per gig, but I only bring this up so you know if you're planning on hosting something in Azure and sending a lot of data outbound, you need to plan for the potential costs with that. The one example I think of from my perspective that I've seen where you really have to consider this is if you are using Azure to host a cloud-based distribution point or cloud distribution group, an SCCM, essentially a cloud-hosted SCCM instance where it's managing it for you. SCCM is used for package deployments and imaging and a number of other things, and that sends a lot of data. So if you're going to use something like that, you have to really plan for the egress charge and try to anticipate how much data is being sent so you can have an idea of how much it's going to cost. This doesn't really become much of a factor because you're only paying a couple cents and it's really per gig, which sending gigs of data doesn't happen a lot unless it's very specific workloads. But I want to call it out so you're aware of it. Consider Azure pricing. And that's it for our Azure Virtual Network overview. This video ended up being a lot longer, and I think I might come back at a different time and record it with virtual machines connected to the VNets. That way you can kind of see the route tables. You get a better idea of, we could do a demo of what it looks like when you're talking across private endpoints to PaaS services, stuff like that, but that'll be future. For now, that's covering this. Our next video is going to be on Azure Firewall and what it looks like to configure that and how that works. So I will see you for that one.